Come on, come on, come on, come on. Okay. Okay, just to confirm before I start, can you see my screen? Can you see my screen?
Yes.
Okay. Okay. Okay, so we're starting on counting methods. Yeah, and as I said, I don't remember when, like, this is one of the, well, I wouldn't say it's difficult though, but it's one of the long topics in statistics. And I feel like if you're doing this for the first time, from counting methods onwards, that's when you feel like the full rate of stats, because from this topic onwards, things are gonna get a bit tricky, but we'll just try to do whatever it is we can, like to try and maximize on the time that we have. And also, I was talking to, who's this, to the lecturer, and I'm not sure, but he might change the way that the tests are conducted, because isn't it tests for now, like with him, it's more or less of you just coming to write the the quizzes, but it's not like I'm teaching you anything, neither is he, you see. So I feel like it's gonna change though. I'm not sure when, but hopefully it does, because things are gonna get a bit tricky. And yeah, that's it. So enough with the formalities and everything. Let's just can I see something? Okay. Let's just start. So for counting methods, three fundamental things that we have, like the three fundamental principles, as I would like to call them, are um, let's say, I feel like this is gonna take maybe 5 minutes me explaining these things before we dwell much onto the questions. So if three fundamental principles that we normally associate with. The first one is gonna be what? Permutation. Then from permutation, we have combinations. Combinations, and we also have the multiplication principle. Multiplication. So what we know is the moment you are dealing with that, the combination. Let me search for something that I compiled. One of the notes. So let me just look for them now. Yes, 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 yes. Okay. So we have what? We have combinations. Let's search for permutations then. So for permutation, what you have to know is the order matters, doesn't it? If it's a permutation. So by order matters, what do you mean? Let's assume we have A, B, and C, isn't it? So let's assume someone asks us to, what do you call this? To formulate or to come up with two different words. Actually, before I do this, let's say, if we say for permutation, like order matters, then for a combination, if a combination, what order doesn't matter. Doesn't matter. This is for what? For a combination. So as I wanted to do now, let's assume someone gives us, what do you mean? Like he gives us three letters A, B, and C. Then they ask us to come up with any 2-letter words from this, isn't it? So what you do is, let's just do it the manual way. You have A, B, and C, isn't it? So you wanna come up with any three, with any 2-letter sequence or group of words. So you might have A, B, A, C, B, A, B, C, C, A, and C, B, isn't it? So if you count these, we have 1, 2, 3, 4, 5, 6. So going back to our, like, how we defined a permutation and combination. If we say order does not matter, what it means is, from this, isn't it, we have 6 permutations. But when it comes to combinations, now we don't have 6 combinations, but we have 3 combinations. How did you come up with this? So for 6 permutations, we just counted what we have, like, as it is, you see. Like, we just counted the number of 2-letter things we had. But now with regards to combinations, AB is the same as BA. This is for what? For a combination. Why? Because we said order doesn't matter. So the moment you say order doesn't matter, it means that AB is literally the same as BA, and you count it once. Then you count this once. Then the same applies to BA. Not BA. I want to say AC and CA. AC is also the same as what? As CA. And also, what else do we have? BC is also the same as what? As CB. So the moment we have this, we know we've eliminated CB and BC. This, you count it as what? As 1. Then you also have AB and BA. This, you count it as what? As 1. Then you also have AC and CA, which you count as what? As 1 also. So hence you have 1, 2, 3 combinations, and 1, 2, 3, 4, 5, 6 permutations. Like, just to confirm on your calculator, like, do you have calculators with you right now? If you do, can you give me the answer to 3 permute 2 and the answer to 3 choose 2? I want you to see something there. What are the answers to this? If you have your calculators with you, if you don't, I can just do it now.
3 permute 2 is 6.
6. 3 choose 2.
It's 3.
3, which confirms what we just wrote there. Here we say that we have 6 permutations, which can be proved by 3 permute 2, which is 6. Then for combinations, we say it is 3 choose 2, which is 3, which is what we just counted. What do you call this? Which is what we just did. Yeah. So it's one and the same thing. So does anyone have a question or anything before we proceed?
Mukoma,
Yeah, Bo.
I don't think like I'm getting this thing of order matters, order doesn't matter. So like my question is like when they say order matters, they are looking at the arrangement, like they are saying arrangement matters in a way. Because like
Yeah, more or less.
it's more like they are reading like how many arrangements. And then that other
Yeah.
one is how many combinations.
Yes, but for combinations now we say that AB is the same as BA, like it's one and the same thing.
Yes.
Yeah.
Okay, no, thank you.
Okay.
Sure, sure.
So let's move on to, I feel like before we do the questions that I sent, let's just do maybe 1 or 2 questions, like just simple questions. Like, let's assume you're given the word Wits. Yeah, Wits as it is. Then you ask, like, how many words can you come up with from this? Like, this is just 1, 2, 3. It's gonna be 4 factorial, which is 4 times 3 times 2 times 1, which is 24. So you can come up with 24 letters from this, isn't it? What else? Now we just have to also take note of what do you call this? Take note of repetition. Let's say we have Wits voters. I can just write Wits. No, it's too long. Sorry. Let me just write one of the success. So with success, we know we have 1, 2, 3, 4, 5, 6, 7 letters. So it's gonna be 7 letters in total. Then from the 7 letters that we have in total, what you know is we have repetitions also. So of the repetitions that we have S, which is repeated 3 times. Then we have C, which is repeated 2 times. U, which is 1. Then E, which is once. So the moment that you ask to come up with like the number of words that you can come up with from this, it's just going to be 7 factorial divided by any repetitions that you have, which is 3 times 2 times 1. 1 factorial is just 1 factorial also. So this will be your answer. That is if you have any repetitions within the words that you're dealing with. This is how we go about it. Like, is this clear for now? I feel like this was already done in class and should be one of the fundamentals. So, yes.
I have a question. So
Okay.
when it comes to this, for example, when you were using the word that you're saying how can I say this? Okay, you have how many letters are they?
7. For
No,
success
I
or
mean
for
for Wits
Wits?
it's 5. For Wits
4.
it's 5.
4.
Oh, 4, yeah. So you're saying it's 4 factorial, ne? But
Yeah.
then how do we know that? Like, why is it not 4 to the power 4?
Oh, okay. You wanna deal with the multiplication principle, I think. Okay, no, we'll see how exactly we incorporate the multiplication principle.
Okay.
Like, we'll see as we do our things. And if I don't address it by the end of this session, please do remind me, because I might forget.
All right.
Okay. Okay. Then, wait, what? Okay. So what we have now is, let's assume, actually, let's just go to the document that I sent. Counting methods. That's this one. Okay. Yeah. Okay, here's the problem now. I'll come back now. Counting methods. Let's see this. Green, please work. Okay. I wanna, like, the function that I told you about. Okay, I found it. Like, where I just write on the paper, not me writing down the question as it is. You can just refer. Okay, so we have this one. Well, I feel like, yeah, let's just do it then. Can you see my screen before I start?
Yes.
Okay. So we're starting with 1.1. It's saying we have 11 luxury cars, 5 of which are VW. So here's the truth to this thing. Like, you'll be given, what do you call this? No, like, it's not only for counting methods, but I feel like that's how I mastered stats, or how I think stats is supposed to be done. So whenever you're given any information, like whatever it is that you're given, just try to write down the information that you have first before you even attempt the question, you see. So here you are told you have 11 luxury cars. So you know that the total number of cars that you have is what? Is 11. Then they're saying you have 5 VW. So for VW you have 5. And for Mac, let me say NB, you have 6 are booked by their owners for service at the workshop in Randburg. Then suppose the mechanic services one car at any given time. This should mean something. Oh, sorry, not this. I wanted to highlight this point. At any given time. Then in how many ways may the cars be serviced in such a way that the VWs are not serviced consecutively? So what this means is, isn't it, it's saying the VW cars are not supposed to be serviced what? Consecutively. So what you do is, because I feel like the moment we do, the moment we do this question, like everything else is also gonna make sense. So please, if you have any questions whatsoever, do ask, because okay, never mind. So we have 11 cars. So these 11 cars are definitely gonna occupy 11 positions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is for the what? For the total, which is for the 11 cars that we have, isn't it? So as we move on now, they are saying, what do you call this? Sorry. In how many ways may the cars be serviced in such a way that the VWs are not serviced consecutively? So if it means that the VWs are not serviced consecutively, it means that these ones, like, they are not supposed to be following each other in a way. So what you do is, the moment you're okay, sorry, can I just answer this call just now? Hello? Hello? Yes? Oh, no problem. I think I'll be there. I should be. I'll confirm as the week progresses. Okay. Okay, I will. Let me just finish off what, because I'm actually in a session right now. Yeah, I'm saying I'm in a session right now. Okay. Okay, I think you can call me maybe around 9. Sharp. Sharp. Okay. Okay, I'm sorry about that. Can you still see my screen? Get out. Can you?
Yes.
Okay. So okay, so as I was saying, they are saying, in how many ways may the cars be serviced in such a way that the VWs are not serviced consecutively?
But it's not the question. The questions is the homepage. We can see the homepage.
Oh, okay, no, it's fine. So, but can you see what I just wrote now, like the total VW, what?
No, it's your homepage.
Oh, okay.
Yeah.
Sense. Okay, so let's just do this. I'll just see the questions on my. I'll use my PC. Like, you have the questions, isn't it? Counting methods. Where did I put it? Where did I put it? Okay, it's this one. Okay, so let me say done. Oh, I feel like that's the problem. And I say new. Where is it? It's this one. Okay. Okay, so it says we have 11. Can you see now? Hello?
I can't see.
You can't?
Mm-mm.
Okay, I'm not sure what's going on. Let me try and see what's going on. Let me share screen. Start. Can you see now?
Yes.
Okay. So we have 11 luxury cars, of which 5 of them are VWs and 6 are what? Mercedes Benz. Then they are saying, suppose the mechanic can only service one at a time. Then in how many ways? May the cars be serviced in such a way that the VW cars are not serviced consecutively? So if they're not serviced consecutively, you know very well that it's like, yeah, like there are different versions to this question. I think we'll see it. I might say they are not serviced consecutively. Then in your quiz, I remember some of you received a question where you were saying the boys are supposed to be sandwiched by girls or something. Like it's literally one and the same thing. So what you do now is the first step is like your main point of concern, regardless of them saying what do you call this? Regardless of him saying the VWs are not serviced consecutively, what you have to consider first, like I would like to say, consider the item that wasn't mentioned. What do I mean by this? Like, isn't it the question is asking you about the VWs, isn't it? So the Mercedes Benz was not mentioned in this, isn't it? So this is what you consider first, and you write down the possible positions that the Mercedes Benz may occupy. So you have 1, 2, 3, 4, 5, 6 positions that can be occupied by what? By the Mercedes. So let me say the MB is going to be represented in white. Then the VW, I'll say it's going to be in what? In green. This is the VW. So you already know that these 6 spots are the ones that are supposed to be occupied by the MB. So what about the VWs now? The VWs can only occupy this position here, which is 1, then 2, 3, 4, 5, 6, 7. So the VWs can occupy either one of these positions that are mentioned, that are indicated in green. Then the Mercedes Benz can only occupy the positions that are indicated in white. You see. So what it means now is when you're doing your operations, like if you saw the document, like with operation 1, where we are saying arrange the what? The Mercedes Benz. So how many of the Mercedes Benz do we have? We have 6. So if we have 6, we know that we can arrange them in what? In 6 Victoria ways. That's the operation 1 for what? For the Mercedes Benz. Then operation 2 now, you go on to what? To the VWs. Like, sorry, I just mixed the colors there. Like, so for the VWs now, isn't it we already say that the VWs are the ones that are indicated in green? So they can only occupy what? 1, 2, 3, 4, 5, 6, 7. So these are 7 what? Positions that can be occupied by the VWs. So the VWs can occupy 7 positions. But how many do we have? We have choose 5. Since we have 5 of the VW cars. So it's going to be what? 7 choose cars. Sorry, 7 choose 5. But now does order matter or it doesn't? Like in this case now, order matters because if VW1 and VW2, like let's assume here we have maybe VW1, then here we have VW2, then in another arrangement we have VW2 and VW1, like they would have swapped positions. Like going back to our definition that we just said there, we said that what do you call this? AB is not equal to BA. This is in the case of a permutation. So this is literally our case, isn't it? So we know that as it is now order matters, and if order matters, then BA is not equal to AB. So this is going to be 7, choose 5. You're going to leave it like this if we'd say that the order doesn't matter. But if it matters, now it's going to be 7, choose 5 times 5 factorial. This on its own is similar to 7 permute 5. Like these expressions are the same. 7 choose 5 times 5 factorial is the same as 7 permute 5. So now your overall answer is going to be 7 permute 5 times 6 factorial. Then you get 1814400. That's how you do such a question. Like, do you have any questions or anything that you need what you call this clarity on? Yes.
I didn't understand all this thing because according to me, I thought maybe the person who will be servicing the car doesn't know which one they should start with. So I mean, I thought maybe for the first operation, for the first case, he will have two choices. Like it will be 2 factorial for me. So it will be 2. We'll have the VW and the Mercedes-Benz. And then like
okay.
I would do, for me, I would do like 11, I would do 11 lines. I would draw 11 lines like you did here. And then I would go to the second step. And then I say like, if he started with the Mercedes-Benz, so for me it will always be 2 because I don't know which one he started with.
Okay, so wait, let me address what you just said now. If he starts with let's assume he starts with the VW, isn't it?
Yeah.
Okay, so here there's gonna be 1, gonna be another one, maybe 2, then there's another one, 3, there's another one, 4, then there's another one, 5, isn't it? Is this, yeah, I feel like this is what you're saying. Then we have the Mercedes-Benz. Let me highlight it in white. We have M, 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 M. This is what you're saying. Hello?
This is what I was saying, but I can see good in like now our answer is wrong because like at the end there we have 2 Mercedes-Benz.
Thank you. That's what I wanted to highlight there. So you can't start with no, actually, like you can actually, because the question is saying VWs are not serviced consecutively. So our main area of focus is not the Mercedes-Benz, but it's the VW. So you can as well do this though. Like it's not that much of a big deal. The problem will start when you do this. 1, 2, let me say this. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 1, 2, 3, 4, 5, 6. Then you have 1, 2, 3, 4, 5. Actually, it's one and the same thing. Yeah, I feel like whatever arrangement that you take, the answer is going to be the same. But that point of view saying you start with 2 factorial because you don't know which one is gonna is going to take, like that doesn't apply here, because in such a situation you can take either one of the two and you're really not concerned Like, you really don't care which one he takes, because the chances of him taking either one of the two, yes, they're different, because you have 6 out of 11 for the Mercedes, then you have 5 out of 11 for what? For the VWs. But that's not your main area of focus right now. Like, you really don't care about what he takes initially.
Okay.
I hope it makes sense.
Understand. Mukoma, can you please draw that 11 operation thing and put Mercedes-Benz first, VW, Mercedes, VW, like the way you did it?
3, 4, 5, 6, 7, 8, 9,
'Cause
10.
Can I also ask?
Yeah.
Can you just repeat? Like, can you actually just repeat it from after the 6 factorial thing? With the
Oh, okay.
yeah. Can you? Cause yeah.
Okay. So let me. So it's here. Right. So we say that we have operation 2. What operation 2 is, isn't it you already said that the Mercedes-Benz can occupy 1, 2, 3, 4, 5, 6, isn't it? And now going back to Nav's what do you call this question? Because isn't it you're asking like if he starts with either one of the two? Now in this case, considering like how I told you that you have to consider, like the first thing that you have to consider most is that aspect or that group of things that was not mentioned. Like that should be your first focus, if I should call it that. So this 6 factorial is gonna be for 1, 2, 3, 4, 5, 6 positions that can be occupied by what? By the Mercedes-Benz. These are the 6 positions that we have here in white. But now for operation 2, now we are saying, the VW can occupy any one of the positions from this one. Because let's assume you start with the VW at this position. It's still fine because the next one is not a VW, but it's a Mercedes-Benz. Then you also go on to this one. It's fine also because it's being sandwiched by what? By 2 whites, which are the Mercedes. So you have 1, 2, 3, 4, 5, 6, 7 possible positions that the VW can occupy. That's what you have now. So you already know that you have 7. But now, does order matter or it doesn't? And we said that order matters. And by order matters, going back to what we just said, like when you open this session, we said that if order matters, then AB is not the same as BA. And these are counted as what? As 2 items. So the very same thing applies. Let's assume, like in a different case, he puts on, let's say this is a VW, another VW, then another VW. Then you have the Mercedes and the Mercedes. So let's assume this is VW1, this is VW2, this is VW3. Then let's assume in another, like let's assume it says someone else also. They say that here is VW2, here's VW3, then here's VW1, isn't it? This is not equal to this if we are saying order matters. So if order matters, like just to try to make it a bit clearer, whenever you see such a question, like when you're arranging things and stuff and everything, just know that order matters. And if order matters, you are dealing with permutations, isn't it? So if you are dealing with permutations now, what we know is we have 7 items, like 7 possible positions that can be occupied. So it's going to be 7 permute. Then how many of the VWs do we have? We said we have 5. So it's going to be 7 permute 5. And as I said earlier on, 7 permute 5 is the same as 7 choose 5 times 5 factorial. These two terms are the same. So as I said, now the answer is going to be 7 permute 5 times 6 factorial. That's how we do it.
Thank you so much. I
No
get it.
problem. Okay, no problem.
I have a question. Wait,
Yes.
So, you're saying if we wanted to use a permutation, it would just be 6 factorial times 7 permute 5.
Yeah,
That's what
this
you're
is
saying.
how. Yeah, this is how we go about this.
Okay, but then you said this statement matters where it says you service one car at a time. What does it mean?
Yes. This is. Oh, thank you so much. Like, if you're saying you can only service one car at a time, it means that the events as they are, like servicing of these cars, is independent. Like, do you know? Like, I'm not sure if I've done it yet. I feel like we're trying to go a bit further, but isn't it? You have independent events, you have mutual
Mm,
exclusive events, you have
yeah.
those other things, exhaustive, what. So the
Mm,
moment you see such a question, you know that firstly, these servicing things, operations are independent. And if they are independent, what it implies now is or actually it implies two things. One, it's independent, and then also I feel like in a way it also tells you about whether or not you should consider the order of these operations, so the order of servicing, like how I tried to explain here. Like, I feel like those are the two things that that statement implies in a way.
So if it says service one car at a time, it means the order matters.
I think so.
Okay.
Okay.
All right. Thank you.
Thank you. Okay, then we go on to question 1.2, which is saying we have 10 luxury cars.
Makoma,
Yeah, bro.
before you can continue and go to question number 2, can we do that again, or the thing of like 11? I wanna actually relate what you told us in class with this question. I want you to help me relating it. So it's 11 operation, so or you draw 11 operation thing.
Yes.
And then like for the first operation, you said we always consider the one that we start with.
That's not mentioned
Yeah,
in the question.
the one that is not mentioned. So out of all the 6 cars, it's six Mercedes Benz, right?
Yeah.
So that means we have 6 options
Yeah.
for the first operation.
Oh, wait. Okay, so you mean for this one, for this operation,
Yeah, so we have 6.
yeah.
For VW, we have 5 now
Okay, you wanna
for the
say we
second
have
operation.
5 here? Okay.
Uh-huh.
We have 5 here. Let me try to use a different color. Then I'll explain because I think I understand what you're saying. Then we have 5
Yeah.
here.
We will have 5 again
So we
from
have
for
4 here. Then 3
yes,
here.
yes, Mokoma.
2, 1.
1.
Then we have 5, 4, 3, 2, 1. Okay. Then what?
Yes. Then I'll just multiply the operation, all the operations. Will it be correct?
So we're trying to multiply all this as it is like this.
Yes.
Let's
16.
see. Okay, so as it seems now, it seems like it's gonna be 6 times 5 squared times 4 squared times 3 squared times 2 squared. No, the answers are a bit different, and let me try to explain why. That one isn't it that
Okay.
you are trying to consider. It was for the arrangement of letters. Is it the one that I told you in class?
Yes, yes.
Okay. So if it's for the arrangement of letters now, this is more or less of a different scenario because here you're servicing two cars one after the other, but at the same time, you have positions on which, oh, actually, first and foremost, the cars that you're dealing with, they are different. Because I remember there's someone who asked me in class, I'm not sure if it's one of you, that if you're not told whether or not the objects that you are dealing with are identical, do you assume that they are identical or they are not? If you are not told of the similarity between them, you assume that your objects are different. Let me try to, because I actually forgotten about that. So if you are not told, like in this case, you just say that you have 10 luxury cars, 6 of the old Audi, then 4 of the you have 5 VWs and 6 MB. And like you never said anything about them being identical or whatsoever. If you are not told, what you do is you assume that the objects that you are dealing with are different. Please keep that in mind. Then, going back to your question now, you cannot arrange them in such a similar manner, because in this sense, like in this case that you're dealing with, there are positions that are supposed to be occupied by the cars. You see? So if there are positions now, what it means is you are not supposed to do what you just did now, because the moment you do this, you are assuming, like let's assume this. Let me just, because isn't it you said you have these 11s, then we had 6, 5, 4, 3 and beyond. Then also at the same time we had 5, 4, 3 and beyond. What this means is it's more or less of a similar operation of 6 factorial times 5 factorial. This implies that you are not considering the conditions that you are given. Like, isn't it it's saying there are positions that are supposed to be occupied, as we mentioned here. But the moment you say 6 factorial and 5 factorial, you are completely disregarding the condition that you are given, regardless of you writing down the 11 positions as you did. I'm not sure if that makes sense.
It makes sense, Mokoman.
Okay.
Can you please go to 1.2 and explain it clearly now?
Okay. 1.2. 1.2 is saying you have 10. You have 10 luxury cars. Then of the 10, you have 6 Audi, and you have 4 Mac. Then are booked by their owners for service at a workshop in Randburg. Then suppose the mechanic services one car at a time. You know that. In how many different ways may the cars be serviced in such a way that the first cars serviced are Audi and the last 2 serviced are Mac. Okay. So is like as a first step, you write down you can, but if you don't want to, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, indicating the positions that you want. So we have 10 now, and we Audi. So the first of the three first, this one, these are Audi, which are in white. Then the last 2, what are the last 2? The last 2 to be serviced are Mac. So it's going to be these last 2. So you have 1, 2, 3, 4, 5. These are 5 positions. 5 positions. So you have 5 positions here, you have 3 there, then you have 2 there. So what it means now is, considering you have this and that, you start with this operation. Let's assume this is N1, this is the second operation, then this is the third operation. So he said that the first 3 to be serviced are Audi. So we are now considering this region only for now. So what does it mean? we know that how many of the Audi cars do we have? We have 6, isn't it? But we want to group the 6 Audi cars in how many positions? Like how many positions are up for grabs here? We have 3 positions. So if we have 3 positions now, does order matter or it doesn't? Yes, order matters, because even if it's, let's assume it's Audi 1, Audi 2, and Audi 3, then in another case it's gonna be Audi 3, Audi 1, and Audi 2. These are considered as 2 different aspects. So the moment you know that it's like this, it's gonna be 6 permit 3. Or if you can't grasp this concept, what it means is you have 6, choose 3. Like you have 6 positions, isn't it? So the 6 positions, how many do you want to choose? You want to choose 3 of the Audi cars. Then now if you have those 3 Audi cars, like how many ways can you group those Audi cars? It's going to be in 3 factorial ways. Yeah, I feel like this explanation makes more sense. So what you do initially is you have 6 Audi cars and you want to group them into 3 positions. So it's going to be 6, choose 3. But of the 3 cars that you have now, in how many ways can you group those cars? It's going to be in what? In 3 factorial ways. So this is the same as what? 6 permute 3. Yeah, I feel like that's a more logical explanation. So this is for N1. Then you go on to N2. N2 is just 5 positions, isn't it? Like, what is it saying? 3 and 2. Okay. So you have, like what do you call this? In this region 1, for N1, it was already occupied by 3. Then N3 is going to be occupied by what? By 2. So you already know that this is going to be what? 5 positions. But we don't care about the order of what? The order, like the arrangement of the cars, like in such positions. Like even if it's Audi, MB, or whatsoever, it's still fine. Like we really don't care about this because it wasn't mentioned. So for the middle position, it's gonna be what? 5 factorial. Now we go on to N3. For N3, they say that in the last 2 to be serviced are Mercedes-Benz. So how many of the MB do we have? We have 4. Then if we have 4, like wanna group them, like how many of the Mercedes-Benz do we want to be associated with the last 2 positions? We want 2. But in how many ways can we group these 2 Mercedes-Benz? It's going to be in what? In 2 factorial ways, which is the same as 4 permute 2. So your final solution is going to be N1, N2, N3, which is 6 permute 3 times 5 factorial times 4 permute 2. This is 5. Does it make sense? Does it make sense?
Yeah, it does, Mukoma. But the problem is like, how do we determine that like the order matters or order doesn't matter? Because I feel like that's the
okay. So I feel like now it goes on to the explanation that I just gave now. Like this makes more sense. We are considering N1 like these first 3 positions, isn't it? So if you have these first 3 positions, we said we have 6 cars, isn't it? 6 of the, what do you call this? Let me look at it. Like we have 6 of the Audi cars, is it? But you wanna choose 3 that can occupy the, like that can be associated with the condition that you are given, which is saying want 3 to be serviced first, which is the first 3, you see. So we have 6, but you want to choose 3 out of the 6. Like we don't know how exactly we're going to do that, isn't it? So the moment we have those 3 cars, in how many ways can we also group those 3 cars, which is going to be times 3 factorial? Because isn't it, we just go back to what we did now, like we have A, B, and C, isn't it? So if A, B, and C, in how many ways can you group A, B, and C? Like how many ways can you group A, B, and C? It's going to be in 3 factorial ways, isn't it? So it can be A, B, C, A, C, B, what, isn't it? So the moment you do that, you know that you have 3 factorial ways. So going back to this now, they're saying you have 6 of the Audi cars, but you want to choose 3 that can occupy the first condition, which is going to be fine. Like, let's assume that's the first operation. It's going to be 6, choose 3. So you have those 3 Audi cars now. But in how many ways can you arrange those 3 Audi cars? It's going to be in 3 factorial ways. So it's going to be 6, choose 3 times 3 factorial. Or actually, just for it to make more sense, isn't it? It disregards the permutation thingy that I just said now, or that I said at the first. You say for your first operation, you are choosing 6, choose 3 cars, isn't it? So you have a pool of 6 cars, then you want to choose 3. This is going to be it. So you have these 3 cars that you have now. But in how many ways can you group these 3 cars? It's going to be in what? In 3 factorial ways. Then you go on to what? To N2, which is going to be times what? 5 factorial. Then you go on to the last condition. How many Mercedes-Benz do you have? You have 4. But of the 4, how many do you want? You have 2. You want 2. So it's going to be 4, choose 2. But now that you have those 2 Mercedes-Benz, in how many ways can you group those Mercedes-Benz? It's going to be in 2 factorial ways. So this, as I said earlier, is just 6 permute 3. Then this is just 4 permute 2.
So what? How was the question gonna be like if it was a combination problem?
Okay, like this is a combination problem on its own, but it's also taking, like, it's also indicating the permutation part of it, in the sense that this condition, the first condition that you have, is a combination problem, isn't it? Like, you already chose 3 cars, but in how many ways can you group those 3 cars? It's going to be in 3 factorial ways, which is just 3, 6 permute 3. So I feel like don't try to distinguish between a combination and a permutation problem as of yet. Like, just consider it as it is. Like, now, like, you have 6 cars, and you want to group them in 3 positions. So you have 6, choose 3. And now you have those 3 cars. In how many ways can you group those 3 cars? It's going to be in 3 factorial ways. Then the middle part is 5. Then the last part, you have 4, isn't it? But you want to choose 2 to occupy the last 2 positions, which is 4, choose 2. But now that you have those 2 cars, in how many ways can you arrange those 2 cars? It's going to be in 2 factorial ways.
Okay, so I have a question.
Mm-hmm.
If the Audi cars are identical and the Mercedes Benz are also like identical, how will like the approach be different?
Okay, thank you. Thank you so much. Okay, so for this one now, let's assume we're told that the cars are identical. Like, cars are identical. Like, isn't it when we started with the word success, and we said in how many ways can you group this? We have 1, 2, 3, 4, 5, 6, 7 factorial divided by 1, 2, 3 factorial times 2 factorial times 1 factorial times 1 factorial, isn't it? Like, this is what we said. So the moment we say this, like, why did we divide by 3 factorial and 2 factorial? It's because we wanted to account for the letter S, which is being repeated 3 times, and C, which is also being repeated 2 times, isn't it? That's the reason why we accounted for this. So if you had said that the Audi and the Mercedes-Benz are the same, then the conditions are also the same. For the first operation, N1, isn't it? It's going to be 6, choose 3, isn't it? Times 3 factorial, as it was. Like, this is fine, isn't it? But what you also have to know is the 3 cars that we just chose now, they are what? They're identical. So if you're identical, we divide by the number of those same cars, which is 3 factorial. So it's going to be 6, choose 3 times 3 factorial divided by 3 factorial, which is 6, choose 3.
Which is basically combination.
which is basically a combination question now.
Okay.
Yes.
All right. Thank
Then
you.
the same applies to the last what do you call this? To the last part. Like this last part is gonna be 4 choose 2 times 2 factorial divided by 2 factorial, which becomes 4 choose 2. Then also for this one now, the middle part, we have 5 positions, isn't it?
Mm-hmm.
But the 5 positions are being occupied by how many thingies? Like how many Audi cars do we have here amongst the 5 positions? Because we already eliminated 3 here, isn't it? So if we already eliminated 3 here, because you say the first 3 are Audi cars. So if you eliminate 3 Audi cars here, you are left with 2, which are the same. So it's going to be divided by what? 2 factorial times. Then in this case also, we also eliminated what? Like we eliminated 2 of the MB. So we are left with 2. So it's going to be what? Like this. So the middle part is going to be 5 factorial divided by 2 factorial times 2 factorial.
All right. Thank you. I get it.
Okay. Yeah, that would be your thing. Like that's how you do such a question. If he told you that they were identical. Now what the hell is this now? Question 1.3. I don't even know what 1.3 is, but let's see. Wait, before we do 1.3, let's do 1.4, because 1.4 is the same as 1.5, which is literally everything that we have been doing. Then 1.6 also, which is what we have been doing. Then 10 luxury cars is the same, also 1.7. So what you're gonna do now is we'll do all questions until 2.1, because 2.1 is a different aspect on its own. Like the sharing thing is, like the sharing what. Like we'll do it also. But let's just start with the first one, where it's saying that. I'm sorry, it stopped sharing. Share. Start. Okay, so let's move on to, I can see. I cannot. Okay. Okay. So let's move on to 1 point before we go on to question number 2. Because I feel like question number 2, like the sharing part, we'll also do it after, because I just want us to focus more on this. Because sharing is more or less of another aspect of counting methods, which is more or less of the last section of this before you go on to probabilities involving counting methods. So I feel like we just have to maximize on this first, then after we'll then move on to the sharing. So we're just gonna focus on questions number 1 point what before we go on to number 2. So let's go on to question 1.4. 1.4 is in yes. Let's go on to 1.4. So 1.4 is saying we have 10 luxury cars, of which 4 of the 10 we have, let's say question 1.4. So of the 10 luxury cars, how many do we have? We have 5 that are VW and 5 which are what? Mercedes Benz. Then are booked by their owners to service at a workshop in Randburg. Then suppose the mechanic is, then in how many ways may the cars be serviced in such a way that among the 5 first cars to be serviced, 2 of them are VWs? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want to concern ourselves mostly with the first 5. This is going to be the first 5. Then those ones are the what? Are the last 5. Then what do we do now? Step number 1, like operation number 1. Isn't it said amongst the first 5 to be serviced, 2 of them are VWs. So we have 5 positions that like not, yeah, like of the 5 positions that we just gave now, or that we have now, like you want 2 of them to be filled by what? By the, what do you call this? Like, isn't it we say the 5, like among the first 5 cars to be serviced, 2 of them are VW cars. So operation number 1, we want to arrange the 2 VWs to occupy the 2 spots that we have in here. So we have 5 VWs that we have. Then we just want to choose 2 only, isn't it? Because it said amongst the first 5, 2 of them are the VWs. So we have 5, then you just want to choose 2, nothing more. So the moment you choose 2, then in how many ways can we group these 2 cars within this yellow bracket? It's going to be in 2 factorial ways, which is the same as what? 5 permute 2. Isn't it? Then we'll go on to the second operation. So we are just dealing with the section that is indicated in yellow here. So we already chose the VW cars. So if we choose 2 VW cars, then we are left with 3 positions that you want to be occupied by what? By Mercedes-Benz. So it's going to be 5 Mercedes-Benz that we have. Then how many are we choosing now? We are choosing 3 to occupy the remaining 3 spots. But in how many ways can we group this? It's going to be in what? In 3 factorial ways, which is the same as 5 permute 3. Then going back to the question that we just asked now, if he had said that the cars are identical, so let me say for an identical thing, for an identical scenario, it was just gonna be 5, choose 2. Then here it's gonna be 5, choose 3 only. Then let me switch to this. Okay. Then we go on to the what? To the third operation. So on the third operation now, like we just want to concern ourselves with the remaining cars that we have here, which are 5. 5 cars that are occupying the 5 positions. So it's gonna be what? 5 factorial. But if you had said that the cars are what? The cars are identical, it's just gonna be 5 factorial divided by, isn't it? We already know that in this yellow region, we already chose 2 of the what? 2 of the VWs. So if we choose 2 of the VWs, how many VWs are left with? We're gonna be left with 3 VWs. Then times 2 this. So let's assume, like for the blue part, I'm assuming that the cars were identical. ID, let me just say ID. That's for it being identical. Then if it was different, then it's the yellow part that we have there. So it's gonna be what? 5 factorial, which is gonna be just as it is. You see? Then the fourth operations now. So the fourth operation, we're saying choose the 2 spots to be filled. 2 spots from the 5 to be filled. So isn't it like we're told that 2 of them are the VWs though? Isn't it? So let me see. I want to see 5 choose 2. 5 choose 2. 5 choose 2. And 5 permute 2. What's the answer? Okay, it's different. It makes sense. So we're told that we are concerning ourselves with 2 positions for now. So the 2 positions that are gonna be occupied by I don't know, the cars that we are told now. Like, isn't it the main emphasis is on the first 5? But within the first 5, we are trying to concern ourselves with only 2 positions, isn't it? That are gonna be filled with, I don't know, the car that they just mentioned there. So we wanna choose 2 positions out of the 5 that we already have. So it's gonna be 5, choose 2. Actually, this can be the first operation because I feel like for it to be sequential, like you say, okay, so we're told that we have 5 positions, but we want to associate ourselves mainly with 2 positions. So we're just gonna choose 2 positions out of the 5 that you have. So this would be maybe your first operation. Then you go on to the second, then you go on to this one, then you go on to this one. Then at the end, what you do is just say 1 times 2 times 3 times 4. Like the operations that you just numbered as 1 through 4. You multiply them, then you get your answer. So I feel like the first thing that you could have done is to associate yourself with the positions first. Like, okay, you have 5 positions, but of the 5, you want to choose 2. That will be your first part. Then, okay, now we go on to what they said, like of the 5, 2 of them are supposed to be VWs. Okay, you have 5 VW cars, but you want to choose 2. So you say 5, choose 2, but in how many ways can you arrange these cars? It's going to be in 2 factorial ways. That's your other operation. Then you're left with 3 positions to be occupied by what? By 5 Mercedes-Benz. But you have 5 Mercedes-Benz, then you want to choose 3. So you have those 3 Mercedes-Benz. But in how many ways can you arrange them? It's going to be in 3 factorial ways. That's fine. Then you go on to the last section. Like you have 5 positions left that can be occupied by 5 cars. So it's going to be in 5 factorial ways. Then that's it. That's how we do this. Any question? Any question? Okay, I feel like it's fine. Then question 1.5 is literally the same as what we just did. Like it's actually the same question. But now we have 6 of the VWs and 4 of the Mercedes. Then wait. So you having this now, what it means is you have 6 of the VWs, 4 of the MB. Then suppose the mechanic services 1 car at any given time. Then in how many different ways can they be serviced? Blah, 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 in such a way that among the first 4, 2 of them are VWs. It's literally the same procedure. Like you can just, yeah, like it's literally the same procedure. Everything that we just discussed now. Then you go on to 1.6. You have 2 Audi, 5 VWs, and 5 MB. Then they're saying in how many different ways may the cars be serviced in such a way that one of the Audi is the first serviced, while 2 of the last year, like this is English, but let's do it. Because I feel like the other thing also is English when it comes to counting methods. Like you get to a point where you actually don't even know what exactly they're asking for, but it's still fine. So you have 10 luxury cars.
Sorry.
Yes.
Have you been writing on the screen? Because I can't see anything. Like it's been the same for a while. Or is it just me?
No, it's the same
okay,
for me as well.
Okay. No, I haven't now. Like I just wanted to start writing when I introduced 1.6.
Oh, because the last thing we saw was the last, like the 5 factorial and whatever.
Oh, okay, makes sense. Like that's where I was. Can you see now?
Yeah.
So you have 10 luxury cars. Then of the 10 luxury, you have 2 that are Audi. 5 which are V. Shoot. Let's do this. You have 2 Audi, 5 VW, and 3 Mercedes-Benz. Then suppose can service one at a time. Now we know in how many different ways may the cars be serviced in such a way that one of the Audi, let's just write the 10 positions first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, let me try to. I cannot see. I cannot see. What's going on here? This thing is not updating. Okay, sorry, I just want to check something. So it's saying you have 2, 5, and 3. Then in how many different ways may the cars be serviced in such a way that one of the Audi vehicles is the first to be serviced, while one of the Audi vehicles is the first to be serviced, okay? Then while 2 of the last 5 to be serviced are VWs. So and while 2 of the last 5, 1, 2, 3, 4, 5. So these are the last 5 that you wanna concern ourselves with. Okay, so operation 1 is obviously gonna want focus more on this, isn't it? Like the first position. So the first position, they are saying that one of the Audi vehicles is the first to be serviced. So if one of the Audi vehicles is first to be serviced, how many Audi vehicles do we have? We have 2. Then how many do you want to choose? You want to choose 1, isn't it? Because they are saying choose 1. But in how many ways can you arrange 1 car? Obviously, it's going to be in what? In 1 factorial ways. Which is just the same as 2 choose 1, which is also the same as 2 permit 1. In the way, it's one and the same thing. Then we go on to operation what? Operation number 2. Operation number 2 now. What's this? 1, 2, 3, 4. Wait, how many things do you have? 10, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No problem. Then we go on to operation number 2. Operation number 2 is saying from the last 5, we wanna choose the 2 spaces to be filled only, isn't it? Which is similar to what we did for this question, isn't it? Like it's literally the same thing. Like for this question, we said we want to choose the 2 spots that are gonna be what filled out of the 5, which are at the end. So it's gonna be 5, choose 2 only. Note why we are not saying 5 permit 2, because we are not choosing any cars, but you are only choosing the spots, and you actually can't arrange positions. Like I feel like it doesn't make sense for you to actually arrange positions. But either way, if you want to arrange the positions, 5 choose 2, if I'm not mistaken, should be the same as 5 permit 2 and 5 permit 2. No, it's not the same, eh? That's right. But nonetheless, yeah. So you actually can't choose positions. Like doesn't make sense. Positions are just positions. You see. So this is operation number 2. Then for operation number 3 now that we have actually chosen the 2 spots to be filled, isn't it? Amongst the last 5. Now we want to arrange the VW cars in the last 2 positions. Like we have 5 positions, isn't it? That are already indicated in blue here. But of the 5 positions, we want 2 of these positions that were already chosen in operation number 2 to be filled by what? By VW cars. So how many VW cars do you have? We have 5. Then how many do you want to choose according to the question? You want to choose 2, isn't it? But in how many ways can we arrange these 2 VW cars? It's going to be times what? In 2 factorial ways, isn't it? So the moment we arrange these in 2 factorial, the moment we arrange these, sorry, can I just silence this? Like we're saying, we wanna arrange the 2 cars in 2 factorial ways. So it's gonna be this, isn't it? So what we have now is we already have this position, isn't it? This position that was already filled, isn't it? Then what other positions do we have? We also have 2 of these 5, isn't it? 2 of these 5. 2 of these 5 now have already been filled also, isn't it? So how many positions do we have left? Like we had 10 positions initially, isn't it? So if we had 10 positions initially, how many did you subtract? We said 1 for the last one, sorry, for the first one, then 2 of the 5. So it's going to be minus 2. So you are left with 7 positions. The main reason why we are not saying 5 of these positions, like 5 of this, isn't it, is because of the 5, our main key, like our main point of interest is the 2 out of the 5. Like we're not considering the whole section as it is, like constituting of 5 positions, but you're only considering it constituting of just 2 positions. So it's 2 out of these 5 that are already filled. Like I'm not sure which one of these, but 2 of the positions were already chosen in this step. So if 2 of them are already chosen in this step, which is 1, which is fine, isn't it? Then 1 of it was already chosen here, which is this one. So how many positions do we have left? We are left with 7 positions, which is 10, which is the total, minus the first one, then minus 2 of the 5. Then you're left with 7. So the last section that we have is 7 of these positions can be occupied anyhow, like in any way that you deem fit. So it's going to be what? 7 factorial. Then your final answer is going to be 7 factorial times 5 choose 2 times 5 permute 2. This is the same as 5 permute 2. Then times 2 permute 1, or just 2 choose 1 or whatever. This is going to be your answer. Is it making sense? Hello?
Yeah, it is.
Yeah.
Okay. Let's move on to what's this?
I'm sorry.
Yeah.
Actually, can you just do a rundown again? Like, just repeat it quickly, if you
Okay,
don't
sure.
mind.
No problem. Okay, I just wanted to see the questions. It's literally like they're just the same. Like it's just different ways of asking them, which is okay. Okay, so let me look at the question. The question is saying we have 10 luxury cars, isn't it? 2 of the Audi 5 VW 3MB. Then they are saying 2 of the Audi, like of the 2 Audi cars that we have, definitely 1 is supposed to occupy the first position. That's the first condition that you're given. Cool. Then we go on to the last, isn't it? So they said amongst the 5, like 5, like amongst the last 5, 2 of the 5 are supposed to be what? Let me see. Which one is it? 2 of the last. This is question 1.6. Okay. So they're saying 2 of the 2 of the last 5 are VWs. So what we did initially was, okay, we consider the first position as he said. So the first position is that position that's going to be occupied by an Audi, of which you already know that we have 2 Audi cars. So you just want to choose 1 out of the 2. Then it's going to be 2 choose 1. Then in how many ways can you arrange that 1 car? Obviously in 1 factorial way. Cool. So 2 choose 1 is the same as 2 permit 1. That's the first operation. Now we go on to the second. So we want to choose 2 operations, 2 positions out of the 5 that we already have, for them to be like our main key points of interest, you see. So if it's our main points of interest, and what it means now is we want to choose 2 positions out of the last 5. So you also consider that as an operation, like as an operation on its own, which is this one, like 5 choose 2. Then we said you are just choosing 2 positions. So like you wanna see in how many ways can you arrange the positions? Like doesn't make sense, you see, because the question was vague, like any two. So the any two can occur at any positions. So you just wanna choose two positions out of the 5 that you have, regardless of whatever order or something that you have. Like the order on the in this method, like in this sense, doesn't matter, you see. So it's gonna be 5, choose 2. Then we go on to the third one now.
Ngoma,
Yes.
aren't we supposed to say like from 5 VW we choose 2, then it'd be 5 choose 2, and then in how many positions should we arrange those 2 factorial? I mean those 2 VWs in these 5 positions,
No,
and
we
then we
also wanna
say,
we also wanna pinpoint those 2 positions out of the 5. Like we also wanna pinpoint them.
but
Like
I feel like at
mhm,
first we would say like we choose 5 VW
mhm,
from 2, and
mhm,
then we choose, it's like 5 choose 2, we choose 2 from
mhm.
5
Yeah,
VW, but like how are we going to arrange those 2 in these 5 positions
in 2 factorial ways.
in 2 factorial ways? So aren't you supposed to times by 2?
No, like the 2 factorial ways, isn't it? It's gonna be this part which I said 5 permit 2. But we also wanna choose 2 positions out of the last 5 that are gonna be occupied by those 2 VWs. Because let's assume, isn't it? Like you have 1, 2, 3, 4, 5, isn't it? So like these are the positions that you have, like the last 5. So like I'm just gonna use, how many colors do I have? I have 1, 2, 3 layers. Actually, I have 5 colors. So I have 1. Like let's assume this is VW1 and this is VW2. So if VW2 like amongst these 5, isn't it? We want to pinpoint 2 of the positions that are going to be occupied by the VWs, isn't it? So it's going to be 5 choose 2. Then I don't know which positions we pick, isn't it? Like let me just assume we pick these 2. Fine. But in now, like now that we actually have the positions, now we want to choose 2 cars, like 2 of the VWs that can fit these 2 positions that we have. So it's going to be what? 5 choose 2. Fine. But in how many ways can these cars now, like the 2 cars that we just chose, like in how many ways can they be arranged in these 2 positions that we have here? It's going to be in what? In 2 factorial ways. So 2 factorial is just equal to 2, isn't it? So let's assume it's going to be, maybe this is VW1 and this is VW2. Right? I'm going to do this. Yeah, let's assume this is VW2. But in another scenario, it might be 3, 4, 5. We are also choosing the last 2 positions. This can be 1, 2, 5, 1, 2, 3, 4, 5. Yes. So in this sense, now this can be VW number. Yeah, what's going on? This. Then I hope it doesn't delete. Okay. So this can be VW number 2, and then this can be VW number 1. Like these are the 2 ways in which we can arrange them. But in this sense, I just assumed that we just take these 2, but it can be any 2 positions. Like it can be this position and this position. It can be this position and this one, you see. So in you not knowing the positions that you're supposed to choose, that's why you had to do operation number 2, such that you already pinpoint the positions that you're going to arrange your cars in, which is fine. Then the moment that you have your positions, now you want to group those 2 cars in the respective positions that you have.
Okay, I understand.
Sharp. Is it fine now? Then for the 4th operation, 7 factorial, I said we have 1 specific position, then we also have 2 specific positions. Then how many positions are we left with? We are left with 7. Then of the 7 positions, in how many ways can we arrange these 7 cars in these 7 positions? Just gonna be in 7 factorial ways. So how you get your answer, it's going to be the multiplication of all your operations. Then that's it. Is it fine? There's this lady who asked me to just round up everything that we were done. Is it fine now?
Yes. Yes, thank you.
Sharp. Okay, then this is the second one. Then let me see the questions. Because as I had said, I don't want to do the sharing ones now, because like, have you done them in class yet? Like where they say sharing, what, like the sharing formula, blah 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 blah. I'm sure we haven't, because I feel like we can do it. I don't know. I think there's something that you have to discuss like soon after I say we are done, because I feel like I'm gonna finish off with this other example. Like I didn't do it in here. I did it as I was preparing for the tutorial, and I felt like it's more or less of a okay. Yeah, now that one I think it tried to cover the multiplication principle. I'm not sure, like we'll see. So they said we have how many numbers? Let's assume we have, oh wait, where did I see it? Let me look for it, because it was actually an interest. Okay, we have 0. Let's assume we have numbers 0, 1, 2. No, let me remove 0. Let me remove this. Okay, so we have 1, 2, 3, 4, 5, and 6, isn't it? So we have these numbers. Then they tell you that we want to come up with a 3-digit number. Like we want to come up with what? With a 3-digit number. So of the 3-digit number, now we are given certain conditions. Sorry. It's not what I think it is. Okay. Yeah, so of the 3-digit numbers that you have, let's assume they say, okay, you have these numbers, isn't it? 1 through 6. Then how many 3-digit numbers can you come up with from these 3-digit numbers? Can someone just try to answer the question? Like if 1, 2, 3, 4, 5, 6 digits, then how many 3-digit numbers can you come up with? Because I feel like it's also similar to the Mississippi problem that say, I feel like there's this guy who once asked it in the civils tutorial. Then say was like, no, like I won't explain it now, but it's gonna matter most on your subsequent quizzes from now. Like you have 6 digits, then how many 3-digit numbers can you get from 6 numbers? Can someone try to answer the question? If not, then I'll just try to explain.
Is it not going to be 6 times 5 times 4?
Only.
Yeah, because we have 3 positions. Now we need a 3-digit number, isn't it?
Yeah. Okay. I
Yeah.
don't know.
So
It's 120, isn't it?
yeah.
Okay. Let me see how I would work it out. It's gonna be times this. Wait, is this correct though? No. Sorry. It's gonna be 1, 2, 3, 4, 5. Where's this? Sorry, I'm using a calculator that I'm familiar with. So yes, this is what I wanted. 6. Come on, where you? Sorry. Okay. Yeah, it is the same, like 3105. So let me try to share my screen, because this thing went on tiny. 6 times 5 times 4 is the answer, of which, like, that's not how I would have done it though. Like, honestly, I didn't know that such a method existed. So you have can you see my screen now? Can you see?
Yeah, we can see, but not the document. Like not where you're writing.
Oh, okay. What happened? What happened? Come on, something happened. Why did it? Okay. Stop. Then present. Start. Can you see where I'm writing now?
No. Yeah, we can.
Okay. Okay, so as our colleague just said, now it's gonna be 6 times 5 times 4, which is the same as this one. But what I would do if it was me, because I didn't know that this answer was actually it is actually correct or not that I think of it. Because isn't it you said you have 3 positions? Then with the 3 positions, what it means is how many numbers can fill up this position? It's gonna be 6 positions, isn't it? Then the moment you subtract 1, then how many numbers are left with? You are left with 5 numbers, isn't it? Then the moment you subtract this one also, you are left with how many? 4 numbers. But going on to where you asked me whether or not it can be to the power, like the multiplication principle. Let's assume this question said, how many 3-digit numbers can you come up with provided repetitions are allowed? How would you go about this question?
It's 6, 6
6
times
which is
3.
6 times 6 times 6, which is going to be 6 to the power 3. So to deal with the multiplication principle, please, it mainly works when you are told that there is a repetition. Okay? When you are told that there is repetition, then that's when the multiplication principle normally applies. Does it answer your question that you had asked me earlier?
Yes, I get it now.
Okay. Yes. So you have 666, which is going to be that. But now, provided you didn't have repetition, it's going to be 6 times 5 times 4. And how I would have done it is, like, how many numbers do you have? 6 numbers, isn't it? But how many numbers do you want out of the 6? You want to choose 3 numbers, isn't it? But now that you want to choose 3 numbers, in how many ways can you arrange these 3 numbers that you already have now? You can arrange the numbers in 3 factorial ways. So this 6 times 5 times 4 is going to be 120. Then 6, choose 3 times 3 factorial, which is the same as 6 permit 3, is also equal to 120. So these two things are the same. Does it make sense? Or should I repeat?
Yeah, just to confirm, when like your original question, it didn't say anything about repetition. That means we can't use the multiplication principle because we assume that repetition is not allowed.
Yep.
Okay, all right.
Not sharp. This is the first one. Then now, what do we do? Let me remove this because we already answered the first one. Then how many, like, this is my second question also, with 1 2 3 4 5 and 6. Then how many three-digit even numbers can you obtain from our given set? I'm waiting. How many 3D
I think it'll be 6.
How did you come up with 6?
It's a 3 operation thing. So I have like 3 even numbers, 2, 4, 6. So for the
Yeah.
first one, for the first operation, I have 3 options,
Mm-hmm.
and then for the second one I have 2. For the last one I have 1. So multiplying
Okay.
all those is 6.
Okay. Let me try to answer. Oh, thank you. Okay, so let me try to answer this. Isn't it? We just said there are no repetitions allowed. I just added this now. So I remember when we were also given this question. Like I'm sure you like he might actually ask you because it was in one of our quizzes. So you have a set of, let's assume it's a set A with 1, 2, 3, 4, 5, 6. Then in how many 3-digit even numbers? So how do you define an even number? An even number is any number that is divisible by what? By 2, isn't it? So also for a number to be divisible by 2, like for any number, be it a 3-digit, a 10-digit, or a million digit or something, for that number to be divisible by 2, what does it mean? It means that the last digit should be what? The last digit should be even. Actually, because I remember how he asked that this question, he was like, how many 3-digit numbers can you obtain from the set, isn't it, that are divisible by 2? So any number that is divisible by 2 is literally just saying an even number at the same time, like it's one and the same thing. So what it means is for the number to be divisible by what? By 2, the last digit on its own should be even. Let's assume you have 937, 938, 7,770, 77,918. You see, so the moment you try to divide this number by 2, it won't be divisible because the last digit is odd. Then this one, the last digit is even, so it can be divisible. It can be divided by 2. Then this one cannot, this one can. So what it means is what matters most is the last digit only. Like the last digit is the one that matters most. Keep that in mind. So going back to our question now, we have 3 operations, like we have 3 positions. We have position 1, position 2, and position 3. So of the 3 positions that we have, isn't it, we want to see how many 3-digit numbers we can obtain that are actually even, like that are divisible by 2. So for this thing to make sense, let's start with the last digit as our first operation. So this can be N1, this can be N2, this can be N3. And also keep in mind that we said no repetitions are allowed. I'll also do like a case where repetitions are allowed. Like, yes, case number 2, repetitions are allowed. So let me just write this one in yellow for it to make sense. Then for this one, I'll try to do it in a different color just for thingy. So we have position 1, position 2, and position 3. This is N1, this is N2, this is N3. Then of the 3 positions that we have, let's start with the yellow one, which is saying no repetitions are allowed. So if we start with the last one, isn't it? If we start with the last number, what does it mean? If we start with the last number, then the last number can only be 2. It can be Okay, so the last number can be 2, it can also be 4, and it can also be 6, isn't it? So if it's 2, 4, or 6, then it means that any of these numbers can literally be like whatever it is that you come up with. But I remember someone asked me this question, like as we're about to leave the civil start. Like, let's assume you treat it as it is, isn't it? Like you have 2, 4, and 6. Like you just treat it as it is. Then you say you have 3 digits here, like 2, 4, and 6. You just subtract. So here you say it's gonna be times 3, isn't it? So now that you have 3 digits here, so it's gonna be 3 minus 6, which is like if you subtract 3 digits, you're left with 3 digits here. Then how many digits can you also include? It's gonna be 2. So you have 2 digits here, 3 digits here, and 3 digits here, isn't it? So you can just say 3 times 2 times 3, like it would make sense. But there's a case now where, let's assume, isn't it? In this case, isn't it, we already said that the first scenario for a number to be even, we have 2, 4, and 6, isn't it? So for it to be actually an even number, it has to be like the last number on its own should be even. But let's assume we put a 2 here. It also means that no, there's a possibility that a 4 can also appear here, isn't it? So for you to somehow incorporate for such, you don't consider this case as a whole, like as one simple case, but you break it down into 3 separate cases, like 3 separate but independent cases. So if you treat it as 3 independent cases, what do? You say case 1. Let's assume the last digit is what? Is 2, isn't it? So you have N3, N2, and N1. So if your last digit is 2 here, like let's assume this is the last digit, isn't it? So if 2 is your last digit, what does it mean? It means that this position on its own can only be occupied by one number. If for this case, if your last digit is 2, so this position can only be occupied by what? By one number. Now this position on its own, how many numbers can occupy this position? Can be 5 positions. So it can be what? It can be what do you call this? It can be 5 numbers, isn't it? So if 5 numbers are occupying this one, then how many numbers can occupy this position? It can be 4 numbers. Similarly, what you can do is you have 1, 2, 3. You already identified that the last digit here is what? Is 2, isn't it? Now that you have already done that, you know that this is going to be occupied by what? By one number. Then you come to this position now. Then you say, how many numbers can occupy this position? Our set is 6. Then we already eliminated 1 here, so it's going to be 5. So 5 times, then how many numbers can occupy this one? 4 numbers can. Then how many numbers can occupy the last one? Only one number can. So for case 1, it's going to be 5 times what? Times 4 times 1, which is going to be 20 cases. Then case number 2. Case number 2 can only occur, let's assume like our digit is what? Is 4, isn't it? So if our digit is 4, then how many numbers can occur here? It's also 1. Then here it's 5. Then here it's 4, which is the same. Then case number 3 is also the same thing, because our last digit, you're assuming it's 6. Because we say 2, said 4 here, then it's 6. So if our last number is 6, then how many numbers can occupy this? It's just 1. Then how many numbers can occupy this one? It can be 5. And for this one, it can be 4. So it's going to be times this. So this is also 20. This is also 20. So how many positions can you come up with? It's 60, which is 20 plus 20 plus 20, which is case number 1 plus case number 2 plus case number 3. The moment you do the summation of these cases, then it's going to be this. And note, you are saying you have case number 1 through 3, and you are saying it can either be case 1 or case number 2 or case number 3. What it means is it's similar to what we did in set theory right there, where we're defining like numerous shaded sections. Like we have this, then we have this, then we have this. Isn't it that time we said it can be area 1, union, area 2, union, area 3. This is literally what we just did here. Like if it's union, we are just saying it can be case number 1, which is similarly 1, or which is union 2, or it can also be 3, which is union. So it's case number 1, case number 2, and case number 3. Like it's literally the same as what you did in set theory. Like, does it make sense? Okay. Does it make sense?
Yeah, it does.
Okay. So yes, that's how you do it. Like if you do not have what do you call this, repetitions. But if you have repetitions now, if repetitions are allowed, what you do is, like, I feel like it's a bit simpler if you have repetitions. Because like it should be simpler. Now that I think of it, you have this. So for this one, blah blah blah. Like you have isn't it, you said you have 2, 4, and 6, isn't it? So if you have 2, 4, and 6, what it means is, for case number 1, as usual, we assume that our last number is gonna be 4. No, let me write it down there. So if your last number is 4, what it means is, how many numbers can you have here? It can only be one number. But how many numbers can you have in these two positions? Obviously, it can be all 6 numbers, because we say the repetitions can be allowed. So your number can actually be 444 if need be, because repetitions are allowed, you see. So if repetitions are allowed, what it means is, how many numbers can you input here? We can input 6 numbers, which is fine. Then how many numbers can you input here? It can also be 6 numbers. So if repetitions are allowed, this is case number 1. So similarly to what we just did there, isn't it, we saw that case number 1 was equal to case number 2, which was also equal to case number 3. So for this one now, it's going to be 6 times 6, which is 36. So if it's 36, then case number 2 is also equal to 36. Case number 3 is equal to 36. So if the question was saying if repetitions are allowed, how many 3 even numbers can you obtain from the set? It was going to be 36 plus 36 plus 36, which is case 1, plus case 2 plus case 3, which is 36 times 3, then 9, 6, 2, 1, and 8. It's going to be 118 cases. So if you have such a question, isn't it, what you do is you break it down into cases. So the moment you have your case numbers, like your cases, then you can try to approach it anyhow. And the moment you want to come up with the final solution or the final answer, then you just sum up all the cases. Then that's it. Is it okay? Hello. Okay. Yeah. So I feel like that was, like this is generally everything that we have up until now. Like all counting methods question are typically what we just did now. Like break it down into into cases if you have to. Then also keep in mind of the conditions that you are also given, etc., etc. Then that's it. Then the other questions that we have are sharing problems, but I don't want to do them now because I'm not like, that's one of the parts that confused me like the most when it came to me doing all this. So I just wanna like familiarize myself with the questions, because I did the questions, but I'm really not as confident as I was with the other ones. You see, so I will do this because as this guy had told me like last week, some of these, like most of these sharing questions are obviously gonna be in, what do you call this, in this, I'm not sure if they're gonna be in this quiz or the quiz next week, because he complained about the set theory ones, like people really didn't do well, I think, and that's a question that he loves the most, you see. So I'm not sure whether it's gonna be this week's quiz or next week's, where it's gonna repeat set theory and a bit of counting methods as we did now. Then the sharing one is gonna be the subsequent week. See, but we'll try to do it before the quiz if you want, because as I said, like some of you told me that it's actually better, like it's actually more logical for us to do the quizzes before, sort of to do these tutorials before we actually do the quizzes, you see, which makes sense. Like I do understand such, honestly, and if you guys are okay with it, we can have a session on, like we'll just move all our sessions to, isn't it you guys right on Thursday? It's Thursdays, and yes, so we move all of our sessions to Wednesday evening. Then we'll just do whatever it is that you'd have done in class to try to prepare you for the quizzes. Because the moment we have these tutorials on Saturdays, it doesn't make sense. Like, yes, you will know what exactly you're supposed to do, but it's already water under the bridge, because you'd have written the quiz and only God knows what you would have gotten there, you see. So I feel like if you can have them on Wednesday, that would be fine. I'm trying to free up myself on Wednesdays, because yeah, but I feel like I will be free because I really don't have much to do. So if you guys request it, we can do the sharing ones. And what's this? I'm not sure. We can do the sharing ones, and what else? What else? It's only the sharings. Then we can try to do as much questions as we can do. Like I feel like that's the only thing that would make sense. I'll also try to look for other questions on my Sakai. Then I'll compile them, even with the answers. Then I send them to you guys. Like, is that arrangement fine with you?
Yeah,
Yes.
it's fine.
Okay. Yeah. So we'll just do that. So.
Oh, Wednesday, what time, Common?
Okay. I don't know. What time would you like? What time do you prefer? I don't know. Because I normally leave campus around 7. Oh no. Is it 7 or 6? Yeah, I think I leave around 7.
Anytime late, it's okay. Even if like it's 8, it's okay.
Okay.
I don't
Sharp.
know.
8. Like I don't have a problem with 8. I don't know about you guys. Like I'll just try to what's going on? Okay, wait. 310599. Like I will try to consult with the others, then I'll hear what they will say, but I'll just propose 8 o'clock, because 8 o'clock also makes sense for me, because I really don't have much to do. Because Thursdays mainly the only thing that I do is this tutoring thing. Like I only have one lecture. I think Wednesday is one of the worst though. But yeah, after my lectures, I will try to go through the stuff. Then after going through the stuff, I will try to explain in the tutorial, which is, I don't know, I think it's fine. Then 8 o'clock, which I say maybe 8 to 10 or 8 to 11. Like there's no set time. The moment we feel like we are done as we are now, then we just proceed. I don't know if that arrangement is okay with you guys.
So about this tutorial 3, Mgoman, like, because he said like he's gonna give us like another tutorial. Does that mean like he's not gonna take the marks of that like tutorial 3 that we wrote?
Oh, he said he's gonna give you another one.
He said he's gonna give us another tutorial because the third 3 it had mistakes.
Oh, okay. I really didn't know. So if that's the case now, then it's fine. It's literally gonna be everything that we just did now.
Okay, so like,
So for
okay,
the Wednesdays start, we try to just do a few questions. Then as some of you had suggested, you can actually be ahead of him if you guys are comfortable with such proceedings. But I feel like being ahead of him doesn't literally make sense because let's assume he's doing counting methods now. Then us in our tutorials are already doing like um I'm just giving for example, already doing like normal distribution. Like doesn't make sense also, you see. So I feel like it's just okay for us to know what exactly is gonna be in the chart. Then we focus on that, you see, before like on Wednesday before the tutorial. So if it does not, like since you guys are taking like what do you call this, like are doing another tag on the basis of these counting methods questions, then I feel like this one was already discarded. Whatever mark that you got is not gonna consider it in a way, because like it's not like it doesn't consider it, but at the end, like you guys will write as many quizzes as possible. Like you write a lot of them, maybe like 15, 16, like we did. We write 16, 15, isn't it? Then at the end you say like, no, considering how you guys have been doing this, what you guys can do is I would take maybe like 8 of your highest, you see. Then you just take 8 or maybe 6. You might be lenient enough to take 6 of your highest, you see. So I feel like the more like it's gonna be best for you to get as much, like as many marks as you can now, because at the end you never know what might happen, you see. So if he's gonna discard this one, then it's fine. It's just gonna repeat this. But if you guys feel like he might bring the sharing ones, because the problem with him is he only tells me what's gonna come in the touch test. He only tells me on Thursday in the morning before I attend the metallurgy touch. You see, because let's assume you would have told me like 2-3 days prior, then it would be your advantage because I will be knowing what exactly is coming. Then we'll do it in these tutorials. You see, but I also try to maybe negotiate with him to tell me in a way like what exactly will be covered, such that you can do it on the Wednesday tats before the tutorials. I'm not sure if it makes sense and you guys agree with such an arrangement. Does it
Yeah,
make
it's
sense?
okay.
Oh, okay, sharp. So yeah, that's generally it. So the thing now with these sessions is, considering that you guys actually paid, the link is only gonna be limited to you only. Like I won't be sharing anything in the group now because it won't be fair for you guys who actually paid. So if you wanna share maybe with a friend or something, it's only you who can. Like you just go on to the meeting, then you just click on the link, then you just share the link if you want. Like it's only you who can. Like I'm not, like I can't do anything because this meeting was only for those guys who paid and the ones who gave excuses saying they're a bit tied up or they have other commitments, but they only watch the recording. So yeah, if you wanna share with your friends, it's only you guys who can. And I'm not sure if it's gonna be accessible, but I would try to just change the settings. Like I will see what I can do. Then if you have any questions also, just come to my inbox. Then I'll try to address as much as you can. And when you also, like, I don't know what happens in your lectures because I don't come, you see, but if you also feel like you are in need of a session, like at any time, like you just post in the group, then we hear what others are saying, then that's it, we'll proceed from there. I'm not sure if such an arrangement is okay with you.
I think that's okay.
Okay. No, if that's okay, then I think this is literally the end of our thing. Thank you so much. I will see you on. Oh, it's Wednesday, isn't it? When? Yeah, if it's Wednesday, then I'll see you on Wednesday. Then if not, then
Can we please
yes.
do two questions that we did during Thursday's quiz test? Like I was confused, like okay.
Do you have them?
Yeah, I took screenshot.
Okay, can you just read it to me? Then I'll try to write down as much as I can.
Okay, let me just open it.
Okay.
Okay, so the first one says the number of different words that can be formed by rearranging letters of the word RO
Yes.
N D
Yes. B.
E D E
Wait. It's RON.
D
Yes.
and then E and then
E
B
what?
E B
It's RONDE.
B
Yes.
U and then
Yes.
L and then T and then
Like,
um and then in such a way that only consonants are at either end.
okay. Okay, so this is the word, isn't it?
Let me just yeah.
So we have RONDEBULT. So we have vowels. Like how many vowels do we have? We have 1, 2, 3. And consonants. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then total, it's gonna be 9. So he said, oh, wait. There's a question that I forgot to. It's not here. Actually, I think I'll try to address it just now. Thank you so much for this. I just thought of it now because it's more or less of a, yeah, it's a common question. So for this one, he said the consonants are what? What was the question? Hello? Hello?
Oh, can you hear me?
Yeah, I can.
It says in such a way that consonants are at either end.
Okay.
Yeah.
So what this means is we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if consonants are at either end, it's gonna be here or here, isn't it?
Yeah.
Okay, so we wanna deal with N1, then we have N2, then we have N3. So for N1, we want a consonant to be here at this first position, isn't it? So what this is literally saying is if consonants like how do I put this? Okay, so I feel like it's more like the odd what that we just did now. Like we have 6 consonants, so we have 6 consonants here. Then here obviously there are gonna be 5 consonants, isn't it? So what it means is it's almost similar to this one. For this one, isn't it? We say 3-digit number with that is divisible by 2. Then we said we have 2, 4, or 6. So if we have 2, 4, or 6, Then we said no, case 1, we have 2 here. So if we have 2, then it's going to be one number. Then how many numbers do we have here? We have 5 numbers. Then how many numbers do we have? We have 4 numbers, isn't it? Then we just multiply it as it is. Then we'll come to this one now. We have 6 consonants that you can actually include here on the first thingy. So if we can include 6 consonants on this number, which is fine, isn't it? So it's going to be include here. Oh wait, I understand the question now. Okay. Now it makes sense. Sorry, let me try to. This is fine. So we have 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are assuming that there is no repetition, I think. Yeah, obviously. So we have 6 consonants that can actually what fit in here. So if 6 consonants are actually here, then we also come to the last one. So if we already take out one consonant from this first position, then how many consonants are left to fill out this position? It's going to be 5 consonants. Isn't it?
Yeah.
So the very same consonants that you already included here and here cannot be included where? Here. Because we're saying there's no repetition. So it's going to be 6 times, I don't know what's here, 10 times. So how many letters are left now? So we have 1, 2, 3, 4, 5, 6, 7. So it's going to be 7. So your answer is going to be 6 by 7 by 5.
Okay, but the way I was thinking about it, I need the condition is that either like consonants are on either end of the word. So
Yeah.
doesn't that mean a consonant can either be at the beginning or it can be at the end, but it cannot occur at the same time?
Oh, okay. You said a consonant can be on either. No, I feel like it actually means that a consonant can either be on the left, can either be on the right, and can also be both, I think. I don't know English now,
Yeah, that
because
was
you're
the
saying
part
like,
that, because
okay.
either means like it can be here or it can be here, but then I don't think it includes both.
Okay, so let's do
That's
the okay. 2, 3, 4, 5, 6, 7, 8, 9. So if we are saying the consonant can be on either, let's assume it's just here for this case. How many consonants are here? It's just gonna be 6, isn't it? Then times how many things are left here? I think it's 8. So it's just gonna be 6 times 8. Then if it's also at the last one here, it's just gonna be 6. Then here it's gonna be 8 also. So it's gonna be 6 times 8 for when it's at the first. Then 8 times 6, which is just 6 times 8 when it's at the last. Then if it's gonna include both also, it's gonna be this. So I'm not sure now which is which, like English. But
okay. Wait. The first one you said it's gonna be 6 times 8. Is it not 8 factorial?
Oh, sorry, it's factorial. Thank you. Because we don't know how many ways we can actually group these, isn't it? Like we have 8 letters, but you can group them in 8 factorial ways. Yes.
Yeah.
Okay. Here it's gonna be 8 factorial. Then here also it's 7 factorial. Sorry, not just 7.
Okay.
Yeah.
Okay. Thank you.
Sharp. Then let me look for this question that I just thought of now. like you will say, please let me. I'm not sure if I still have it though. Like I didn't include it here. I don't know why. Just hang on a bit. Just hang on a bit. Let me try to think of it. Like he will say, oh yes. I feel like this makes sense. You have a word success. Yeah. No, I don't want to write success. I want a word that's long. I'm just gonna write a random word because water in there's no repetition, isn't it? No, I don't want repetition. Water in. Yes. This is fine, isn't it? Like we have a word like water in. Water in. So for water in, let's assume he asks you the first question: how many different words can you try to formulate from this? So it's going to be 1, 2, 3, 4, 5, 6, 7, which is just going to be 7 factorial, isn't it? Then on this one, he said, how many words can you formulate such that all the vowels are together, isn't it? So if all the vowels are together, it's going to be A, E, I. Then we have W, T, R, and N, isn't it? So what this means is, if all the vowels are together as they are like this, it means that whatever it is, that's like we'll consider this as one letter. If that's the case, like I'm doing this with regards to words, isn't it? But he normally does it with regards to people. Like let's assume he says a boy and a girl are supposed to be moving together. Like let's assume you have like 8 couples, isn't it? Then you say, in how many ways can you arrange these couples in such a way that a couple sticks together, you see? So in this way, I just took it now literally in terms of words. Like we have vowels and consonants. Then you ask you, like, in how many ways can you arrange the words in this word in such a way that all the vowels move together and the consonants are just, So what this means is you consider A, E, and I as what? As one thing, like as one letter. Then if you consider this as one letter, how many positions do you have left now? We have one position. Let me do this. We have one position. Okay, so this is going to be position 1. Then this is going to be position 2. This is position 3. This is position 4. Then this, as it is, it's going to be considered as position number 5. So what it means is, in how many ways can you arrange this? You can arrange this in 5 factorial ways, because you're considering this as one word, isn't it? Which is fine. But also, it's going to be times, in how many ways can you arrange the consonants, the vowels themselves within this group that we just classified them in? It's going to be in 3 factorial ways. So it's going to be 5 factorial times 3 factorial. So what you do is initially, or you can just start with 3 factorial, because you say the vowels or the couple. If it's a couple, then it's going to be 2 factorial, isn't it? So in this sense now, it's going to be, what do you call this? It's going to be the vowels as they are, which is A, E, and I, of which there are 3. So it's going to be 3 factorial, as I saw. It's going to be 3 factorial, as I did here, then times. In how many ways can you arrange these words now? Of which these words, like, initially we had 1, 2, 3, 4, 5, 6, 7 words, isn't it? But now we're given a restriction that no, please make sure that all the vowels move together, like they're supposed to be treated as one. So if they're treated as one, you no longer have 7 positions, but you have 1, 2, 3, 4, 5 positions. Which in how many ways can these 5 positions be grouped? We know that these 5 positions can be grouped in what? In 1, 2, 3, 4, 5. factorial ways. So that would be your answer. Yeah. Does it make sense? Or should I repeat?
Makes sense.
Okay. Yeah, so I forgot about such a question also. Like, just keep this in mind. So you group the positions as they are first, then you go on to the group or the sub thingy that you have, then you also arrange it in as many factorial ways as you can. So here we have 5 positions, which is like we have 5 positions, which are these positions. Then you group them in what? In 5 factorial ways, which is fine. But now also you want to group these ones because you have A, E, and I. But you can also come up with the combination like A, I, E, then I, E, A, what, like, you can come up with any arrangement that you want or that you have also. Then this would make sense. And also, if you have repetition in such a case, let's assume you had in our word, isn't it? You had you come here, then you have water in. Let me put another A here. So if you have another A, then what it means is in how many ways can you arrange this? It's going to be in 8 factorial ways divided by 2 factorial. Why? Because you have a repetition for A, like you have 2 A's appearing here. That would be a first. Then for all vowels to be together, now we have 8 positions. 4, 5, 6, 7, 8, which are for water, isn't it? We said it's going to be water in, then another A here. So we have 8 positions, but how many vowels do we have? We have 1, 2, 3, 4 vowels, which is A, E, I, and another A. So this is 1, 2, 3. It's going to be in these 4 positions. So if it's 4 positions, then how many positions do we have? Because isn't it we have W, T, R, and N. So now that you want to group these, how can you group these? Now it's going to be 1, 2, 3, 4, 5 factorial ways, as usual. But is it? Yeah, 1, 2, 3, 4, 5. Yes. 1, 2, 3, 4. Yeah, oh, wait. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yes, it's fine. It's going to be in 5 factorial ways, isn't it? So you have 1, position 1, position 2, position 3, position 4. Then this is position 5 on its own. So it's going to be in 5 factorial ways, isn't it? Times. But now, in how many ways can you group this? It's going to be in 1, 2, 3, 4 factorial ways. But you also have a repetition for A. So it's going to be divided by 2 factorial. So it's going to be, your final answer will be 5 factorial times 4 factorial divided by 2 factorial. Since you have a repetition for what? For A. That's why we're dividing there. So whenever you have repetitions, please account for them and divide by the number of repetitions that you actually have. Is it fine? Is it okay? Okay, any more questions? Any more questions? Okay, so I assume this is the...
Oh,
Yes?
I have another one,
Okay.
but this one includes an or. So it says, can I read it out?
Yeah, you can.
It says, how many words can be formed by rearranging all the letters in the word Witwatersrand in such a way each of the words start with the letter W and end with letter N or D?
Oh, now this is fine now. Like, it makes sense. Okay, so it's this fits what we have one. How many words do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 letters. So of the 14, how many are repeating? I think it's W, which is 2. Then we have T, which is 2 also. Then we have A, which is A, which is 2. Then we have an S, which is 1, 2. Then W, we have it I, it's gonna be 1. T, we already have it. Then what do we have also? A, we have it. T, we have it. E, it's gonna be 1. Then R, it's gonna be 2. Then D, it's gonna be 1. N, it's also gonna be 1. So it's 2, 4, 6, 8, 10, 11, 12, 13, 14. That's everything that we have. Then the conditions we're saying, the first is what? The first is W, isn't it?
In such a way, each of the words start with the letter W and end with the letter N or D.
Okay. So we have N. Then here we also have W, but we end with D. So now we have 14 letters, isn't it? So how many positions do we have here? We have 12 positions in the middle. So we have 12, 13, 14, 12, 13, 14, isn't it? These are the two cases that we have. So our end conditions, we have an N, then also have a D. So let's start with this one. So it's saying the first letter is going to be a W, isn't it? Then how many W's do we have?
We have 2.
What's 2 choose 1? 2 choose 1 should be 2. Oh yeah, let's go. Oh, 2 choose 1. Yes. Okay. So what it means is for this one, isn't it? For the first position, we have how many W's do we have? We have 2 W's, isn't it? But you wanna choose what? 1, isn't it?
Mm-hmm.
But in how many ways can we arrange this W, like this one W? It's gonna be in what? In 1 factorial way. But isn't it we already have repetition? So if we have repetition, we divide by what? By 2 factorial. So 2 choose 1 times 1 factorial is just the same, like it's equal to 2. Let me erase this. 2 choose 1 times 1 factorial is the same as 2 permit 1, which is the same as 2. So 2 divided by 2 factorial is just the same as what? As 1. So we already know that the number here is going to be 1, isn't it? Then how many? Sorry?
I said okay.
Okay. Then for the last one, you say it with an N. So with an N, we already have 1 N. So 1 choose 1 divided by 1 factorial. It's going to be 1 also. So it's going to be 1 times 1, then times 12 divided by. But what we know is amongst these 12 now, we also have these repetitions. So we know that W is being said to repeat twice, isn't it? But we already took out 1 W for the first letter. So we only have 1 W. So it's going to be 1 factorial for W, then 2 factorial for T, 2 factorial for A, 2 factorial for S, 1 factorial for I, 1 factorial for E, then 2 factorial for R, then 1 factorial for what? For D. That's one. So it's going to be 12 divided by 1 factorial, 2 factorial, 2 factorial, 2 factorial, etc., etc. Then it's going to be this. Then the OR, the moment you're in OR, just know very well that it's union. And if it's union, it means you are adding. So if you are adding, then it's going to be the answer that, that you get here, plus you do the same here. But now, isn't it saying it's ending with a D? But how many D's do we have? We only have one. So we know it's a 1 here. Then W is the same procedure. Then you get a 1 here. Then if you get a 1, then we come to the middle. You have 12 letters. But with the 12 letters, it's literally the same conditions that you just said now. So it's going to be 12 divided by the same thing. So the answer is going to be the answer that you get here times 2, since they are the same.
Okay.
Okay.
Thank you.
Now, welcome. Any more questions? Any more questions? Yeah, this thing is spanned for about 2.5 hours. Yeah. Okay, so do you have any more questions?
No.
Okay. Yeah, so I guess this is it. Thank you so much for attending. Then I think I will see you on our next session that we have on Wednesday. If that's what you guys would want, just communicate, then we'll see what we can do. So yeah, thank you so much.
Thanks, man.
Sharp. I'll end the thing now.